So this is lesson 2.4, mid-segments of a triangle. So we just did our folding thing. We created the two midpoints of our triangle, connected them. So the lesson here is that that segment is called a mid-segment. Okay? So the mid-segment by definition connects the two midpoints of two sides of a triangle. Okay? That's the definition right here. The theorem says the mid-segment of a triangle always is parallel to the third side and half the length of that third side. Okay, so there's really two parts to this theorem: parallel and half the length of the third side. Okay, this second one, I prefer this. I like to think of it this way: 2 times the midsegment. So in other words, if you double the midsegment, double the length of the midsegment, it equals the parallel side. This kind of sums it all up. This, if you just think of it that way, 2 times the midsegment equals the parallel side. So that's the midsegment theorem, triangle midsegment theorem. All right, well, when we've learned about parallel lines before, what does that usually give us information about? When we have lines that are parallel, we're looking for what relationships equal what? Parallel lines, did they give us information about side lengths? What was it? Angle measures, right? Remember corresponding angles, alternate interior, alternate exterior, same side interior, right? So the fact that these are parallel is also going to give us some information about some of the angles in this triangle. Okay, but let's start here. We're going to do this together. Name 3 pairs of parallel segments. So what we want to do in this triangle, they've actually drawn all 3 midsegments. You can see that this is the midpoint because this is marked with 3 and this is marked with 3, so it's showing that it's exactly in the middle, right? And the same thing on the other sides. So they've actually drawn all 3 midsegments of this triangle at the same time. So 3 pairs of parallel segments. If I start with that RS that I just highlighted, it's parallel to what side of the big triangle? What side is it parallel to? What happened to my recording? Is it gone? No, it's still going. RS is parallel to what? DF, right. Okay. What about RT? Parallel to what? EF. Good. And what's left here? ST parallel to ED. You guys see that? Okay, now again, since they're parallel, it's going to give us some information about some angles. So this one's asking us if the measure of angle EDF, D is the vertex. That's this angle right here. So the measure of angle EDF is 42 degrees. What other angles would be 42? In other words, what other angles would be congruent to that yellow angle there? So look for corresponding angles. If we know that this line is parallel to this line, we can think of this red line as the transversal. This would be a corresponding angle. You guys see that? So that's angle ERS. Is that what that says? Give me another one. This time think about the red being parallel to the red and the blue one being the transversal. Find me another corresponding angle. Yeah, Jack. Yep. STF right here. Can anybody find the other one? It's not corresponding now. Sydney. Good. RST right here. Because what kind of angles are those? Those are alternate interior. Yeah, sort of see the Z there. Okay, so RST. You could do the same thing with other angles in this diagram. I think this is becoming a little too much to look at. Let's start fresh here. If RT is 12, the length of RT is 12. What is the length of EF? Alex. Yep. Okay, we said 2 times the midsegment equals the parallel side, right? So if we're looking for EF, that's the parallel side. That means 2 times 12 gives us 24 for the parallel side. What about ES? What is the length of ES, Maeve? 12. How do you know that? Yep, it's half of EF because point S is the midpoint. So, how many little tick marks should I put on segment RT? If I'm talking about marking things congruence with little tick marks, how many tick marks should go on RT? 1, 2, or 3? Skylar, what do you think? Is RT congruent to? Yep. Because we just said that this is 12, that makes this 12, this is 12, right? So it's congruent to those other two. How many tick marks should I put on RS? 2. Because it's half the length of DF, and so is DT and TF. Okay, that leaves 1 here. So notice that when we draw all 3 midsegments, there's 4 smaller triangles that are created inside the original big one. All 4 of those triangles are exactly the same as each other. They all have a side with 1 tick mark, a side with 2 tick marks, and a side with 3 tick marks. Based on the angles, this angle, this angle, this angle, this angle, we said were the same. They're going to be exactly the same as each other. Okay, name 2 segments congruent to segment RS. 2 segments congruent to RS. So we just kind of marked that. What's that going to be? Lindsay, what do you think? So RS is half the length, yep, DT and TF. All right, solve for x if TS is x minus 1. TS is x minus 1, and DE is 3x minus 7. So this is where we're going to use that 2 times the midsegment equals the parallel side. So 2 times the mid-segment is x minus 1 equals the parallel side, which is 3x minus 7. So we have to distribute. We get 2x minus 2 equals 3x minus 7. Subtract 2x from both sides. We're going to get negative 2 equals x minus 7. Add 7 to both sides, and x equals 5. Find the length of DE. So we're going to plug in 5. DE is 3 times 5 minus 7, and that's 8. And TS, when we plug in 5, hopefully we get 4, because we need it to be half of DE, right? So 5 minus 1 is 4. Any questions? All right, so these three at the bottom here, same idea. Find the value of x. What is the equation we're going to write for number 19? Think of that 2 times the midsegment equals the parallel side. So what should I write here? Sydney? Yes. I know you probably could have done that one in your head, but I like you to get in the habit of writing the equations. So then you just divide by 2 on both sides, you get 13. Okay, try 20 and 20. Any questions on those? Okay. So the next page might seem unrelated, but it's sort of related. There's something called coordinate geometry, where all these relationships and stuff can be investigated and explored on a coordinate plane, x-axis, y-axis, on a coordinate plane. So we did dabble with this formula already before. I sort of gave it to you as a preview one day. The midpoint formula is used to find the midpoint, obviously, on a coordinate plane. So this formula here is on the coordinate plane. Basically, if you have 2 points given to you, if you use this formula, it finds you the midpoint of that segment. Now, they do start off talking about on a number line, so you can find the midpoint of 2 points on a number line, but that's not going to be that formula. That's just going to be basically if you have 2 points on a number line or on a ruler or whatever you want to think of it as. The midpoint is the halfway point between those two numbers. Another word for the halfway point between two numbers is the average, right? If you get 100 on a test and 80 on a test, your average is the halfway point between 80 and 100, right? So to get the average, what do? Add them up and divide by, in this case, 2, because there's 2 numbers, right? So on a number line, you're really just finding the average of the 2 numbers. So it's just going to be A plus B over 2. So in other words, the 2 numbers, add them together, divide by 2. However, when you get to this midpoint formula on the coordinate plane, it's the same idea, except you've got x coordinates and y coordinates. So you have to find the average of the x coordinates first, and that's your new x, and then the average of the y coordinates, and that's your new y. Okay? So this formula gives you x of the midpoint, y of the midpoint. So I'm going to kind of call it xmym, right? So to get the midpoint x coordinate and the midpoint y coordinate, you're doing the average of the x's, comma, the average of the y. So if you look at these examples here. The first one is actually on a number line. And you can tell it's on the number line because these are not ordered pairs, right? They're just single numbers. So FG has endpoints -3 and 4. The midpoint, we're just going to do -3 plus 7. Did I say 4? It's interesting. Sometimes the wrong number comes out. But -3 plus 7 over 2. That's how we're going to find the average of these two numbers. That's 4 over 2 is just 2. So the average, or the halfway point, or the midpoint on a number line of -3 and 7 is 2. That's 5 away from -2, and it's 5 away from 7. You guys see that? Okay. The next one is going to be using the formula, the midpoint formula, on the coordinate plane. Oops. The endpoints of AB are 3, -4, and -5, 6. So we're going to call this x1, y1, x2, y2. We're trying to find the midpoint. So xm, ym, right? Equals, okay, we have to add the x's. 3 plus -5 over 2, and then -4 plus 6 over 2. That gets us 3 plus -5 is -2 over 2 is -1, and 6 plus -4 is is positive 2 over 2, which is 1. So our midpoint is just -1, 1. Number 3 is asking you not to find the midpoint, but to find the other endpoint. This one's a little bit different. There's a couple ways of doing it. So they're telling you the midpoint is 2, -1. So this is xm, ym. This is the midpoint. One endpoint is x1, y1. Find the other endpoint. So this is a little different. Well, in order to get the x coordinate using our midpoint formula, we needed to do x1 plus x2 over 2, and that gives us xm, right? The x coordinate of the midpoint. And then separately, we need to think about the y. y1 plus y2 over 2 gives us the y coordinate of the midpoint. So now if we plug in what we know, we can solve to find the other endpoint. So let's switch colors here, right? x1 is right here. So that's -3. Right? Plus x2 is what we don't know. Over 2 equals xm we have right here is 2. Now to solve this, multiply both sides by 2. It cancels on the left. We get -3 plus x2 equals 4. Add 3 to both sides, and x2 is 7. And then you can do the same thing with the y's. We know one y coordinate is 5. We need the other y coordinate. We know the midpoint y coordinate is -1. Here. So again, multiply both sides by 2. And it cancels on the left. And we get 5 plus y2 equals negative 2. Subtract 5, and y2 equals negative 7. So find the coordinates of the other endpoint. 7, negative 7. I do have a bit of a shortcut trick for that. It's just a different way of looking at it. I'll show it to you right over here. So if you set this problem up as endpoint, midpoint, endpoint, one on top of the other. This is the mid. Okay? So endpoint, midpoint in the middle, and then endpoint. So the endpoint they give you is negative 3, 5. The midpoint they give you is 2, negative 1. If we think of this as, well, the midpoint is halfway between the two endpoints, right? So look at the x's. To get from negative 3 to 2, what would you have to add? To get from negative 3 to positive 2, what would you have to add? Five. So, plus 5. Well, if the midpoint is halfway between, that means it should be another plus 5 to get to the other endpoint. Right? So you do 2 plus 5 and you get, follow that? From negative 3 to 2 is 5, so then we have to go another 5 to get to 7. Do the same thing with the y's. 5 to get to a negative 1, what do you have to add? You're at positive 5, you have to get to a negative 1. So we have to add a negative, right? Or subtract 6, right? So do the same thing here. Negative 1 minus 6 is negative 7. So see how it's the same answer we got before. Just a different way of doing it. Okay, some people prefer that method. Okay, so I'm going to have you try numbers 3 and 4 on your own. Okay, so this one should be negative 8 plus negative 2 over 2, and 3 plus 5 over 2. And that comes out to negative 10 over 2, which is negative 5. And 3 plus 5 is 8 over 2, which is 4. Make sure you put your answer in parentheses to show that it's an ordered pair. And then this one is 8 plus negative 1 over 2, and negative 2 plus 5 over 2. Both of these come out odd numbers, so it should be 3.5, comma, 1.5 as your ordered pair. Okay, so this last question kind of brings these two pieces of our lesson together. And it says, on this coordinate plane, draw a triangle ABC with these coordinates. So do this with me. Point A is at 3, 9. We'll go to the right 3 and up 9, and that's point A. Point B is at the point 5, 1. We're going to go over 5, up 1, and that's point B. And point C is at 9, 5. So over 9, up 5, and that's point C. So we have this triangle on the coordinate plane now. So what they want us to do is find the midpoints so that we can draw the midsegments, right? So we're going to basically find the midpoint of each side. Now, we could estimate what the midpoint is, but we want to practice calculating it. So the midpoint of AB, they want us to call that point D. Well, to find the midpoint of AB, I have to use coordinates from A and coordinates from B, and the formula. So 3 plus 5 over 2, 9 plus 1 over 2, which is 4, 5. And then they want E to be the midpoint of AC. So we have to use the coordinates from A and C. And then point F is the midpoint of BC. So we have to use the coordinates from B and C. I'm going to give you a minute to do that. So I got point D is the midpoint of AB is 4, 5. So if I go over 4 to the right and 5 up, it lands me right here. Makes sense. That's the midpoint of AB, right? And then midpoint of AC is 6, 7. So over 6, up 7. Makes sense. Lands in the right spot. F is the midpoint of BC is 7, 3. Again, it makes sense. So we can then draw the midsegments of that triangle by connecting the midpoints. Okay, so there's a practice attached to this packet. You can have the rest of the period to work on it, and whatever you don't finish will be for homework.